We're in your algebra and we're on quiz 42. So let's get going here and get through this. Basically, it shows you on your quiz the sections 5.2, 5.1.2 to 5.1.3. You can know the sections to go back and review those sections before you take it, and you'll get, there's some usually theorems or something that make things easier. You don't have to just think on your own like, oh, what is this? It's right there in your book. Everything is in your book. So you just have to find it. Sometimes it's kind of hard to find in this book. But anyway, so the first one says solve the exercises and write your answers in space at the left. Leave the answers in radical form. Radical form means in the square root form, right? So an altitude of an equilateral triangle is 12 inches. Find the side. So, this is on number 3 on page 250. So first of all, I drew it. Go ahead and draw these two. This is going to be your triangle here, right? And this equilateral means all these sides are equal, but we don't know the side. But we know the altitude now. We know this is 12. So they want to know, we want to know now, we want to know what this S is, what this side is, right? Well, there's a secret formula here. So you can sit here all day and go through the whole Pythagorean theorem and everything. Or you can just go by what your book says of a formula that's already there. That's easy to fill in. So let's look on page 3 on 250 on page 3, or number 3 on 250. Okay, is number 3 at the top, sorry. See if I can read this to you. You might have to zoom in or get your book out. Prove that if H is the altitude of the equilateral triangle, that's what we have, we know what H is, then one side, and here's the formula. One side is 2/3 H times the square root of 3. So now we can take this here, 2/3 times H times the square root of 3, and use that and just fill in the numbers. How easy is that? So we can fill in these numbers. So it says, if on page 3, it says if an altitude of an equilateral triangle is then one side is 2/3 height. So here's our formula. I just got it right out of your book. So that's our formula we got to use. Now we just plug in. We're going to plug in that height, right? So we have the side's going to equal 2/3. We plug in 12. 12 is the height. Remember, we know that 12 is the height here. We plug in 12 times the square root of 3. So I just plugged it in. And so 2/3 times 12, 24 divided by 3 is going to be 8, right? 24 divided by 3 is 8. So it's going to be 8 times the square root of 3 in radical form. So one side is going to be 8 times the square root of 3. Just by filling in this 12 here and this here, filling in the height, we can get the side right away. We just fill in the height. So you've got to have that number. Otherwise, I would sit here and like, okay, we have to figure this out. We got to try to do the Pythagorean theorem, and it just take a long, because it is a process. But they already have the formula there. It's kind of like Einstein's formula. He took a long time to figure out Einstein's formula, right? And so now we can just plug in numbers, right? So anyway, so let's go on to number 2. Number 2 said, find the area of a triangle in number 1. Oh, okay. So we had to have number 1's answer before we could get number 2. So find the area of the triangle in number 1. We want the area now. We know the side. The side is 8 times the square root of 3. So now we know the area of any triangle is going to be 1/2 base times height. So it's going to be area equals 1/2, and we know the base now. What's the base? The base is going to be this up here, so the base is going to be 8. It's going to be the sides. It's going to be 8 times the square root of 3. So we plugged in the b, 8 times the square root of 3, and the height we know before is 12. So all we did was plug in numbers here. So now we have area equals, 1/2 H is 4, so 4 times the square root of 3 times 12. 4 times 12 here is 48. So it's going to be 48 times the square root of 3 square inches in radical form and reduced form. You can't reduce it more than that. For 48 times the square root of 3. So first of all, we had to have this formula to get this, to get the base, the side, and then we just plug in 1/2 base times the height being 12. Easy, easy. Easy peasy, right? So let's go on to number 3. Now this is the one that looks like, oh dear, I can't do this. No, you can, because this is Hero's formula. And it's all it is, a formula with plugging things in again. So of course, they're gonna make you do this a number of times on the test too. So let's find out. So this is find the area of a triangle that has sides 5, 12, and 13. We know it's not a, that it's not a, that it's not a right triangle. So we can go through the whole Einstein thing to try to get this formula, but it's already in your book. And it's already in your book, again, on this page. Number 9, this hidden formula they got here, Hero's formula. Let's put it closer so you can see. So it's, you can see there, it's the square root formula. There's 2 steps. 2s equals a plus b plus c, and then you find the side. You find the side and you plug in the numbers and you get the answer. It's really easy to do. It's just plugging in now. So otherwise you wouldn't be able to do this, because it looks like, oh, find the area, but we can't. How do we do this? The only way we can do is using Hero's formula. We can do it another way, but it'd be an Einstein way. So let's go this way. So here we have 5, the sides are 5, 13, and 12. So this is the first step right here. So you got the first step here, is 2s equal a, b, and c. You're gonna add all these together. So 2s equals 5 plus 12 plus 13. 5 plus 13 plus 12 equals 30. And then you have to divide by 2. So you've got s now. You know what s is gonna be. S is gonna be 15, right? So now we're gonna plug in s, and we're gonna plug in all those sides. That's all we do. So here we go. Here's our big formula. Got it right from the book, right? So now we have, the formula is s times s minus a times s minus b times s minus c. So, so we found out that s is 15. So 15 times 15 minus 5 is 10. 15 minus 12 is 3. 15 minus 13 is 2. So now we're going to multiply all these together. 15 times 10 times 3 times 2. Well, I just did 15 first, and then I did 10 times 6 is 60. So I have 15 and 60. 15 times 60 is going to be 900. Well, right away for one thing, 9, if you do the square root of 9, it's going to be 3, and the square root of 100 is going to be 10. So we're going to get out of that. We're going to be able to find the square root of 900 easily. It's going to be basically 3 times 10. So the square root of 900, 30 times 30 is 900. So the square root of 900 is going to be 30. So this is going to be 30 square inches. What a fun way. Because here, all of this, and we found 30 square inches. The square root of 900, 30 times 30 is 900. So basically I took the 9 out and the 100 out, and 3 times 10. Whenever you do that, you can get that 9 out and you get the 100 out, because 3 and 10, there we go. We got 30 square inches. So that's pretty good. So let's go on to the last one on quiz. So this one, again, we're going to have to looks like we're going to have to use that Hero's formula again, So anyway, this is find the area of a rhombus. What's a rhombus? A rhombus is a parallelogram that has equal sides. Now a square is a type of rhombus. A square would be having right angles like this, and a square would be different. A square is a type of rhombus, but a rhombus can be a parallelogram like this. So that means the diagonals on a square are going to be equal, but the diagonals on a rhombus are not going to be equal. So you're going to find the sides. The sides of the rhombus are going to be 10, 10, 10, 10. Each side is going to be 10, and the diagonal is going to be 12. And so there's another easy thing to go with this. So it makes it easy. But I looked and said the area of the rhombus equals 1/2 the product of the diagonals. And then I was like, oh, okay. you know, can we use that? We only have one diagonal, you know, so, but to know this, because this is going to be a test question, to know the area of a rhombus equals 1/2 the product of the diagonals. But these diagonals, we don't know these diagonals, and so, you know, we don't want to actually, we want to know what the other diagonal is. So that's what we're looking for first. So we only need one. So you can look at that. That's on number 7. This will be on your test, but really it doesn't have anything to do with this. So something else. What we need to do to be able to find the area of the rhombus. Now we only have one diagonal, so to do that we'd have to have 2 diagonals. But if we look here, we have a triangle, and we know the triangle is 10, 10 by 12. Oh, great! It's not a right triangle, but we have three different sides, so we can use our hero's formula, right? So since we have 3 sides, 1, 2, 3, and then if we find that, then we can be able to just this one is going to be equal to this one, so we're just going to times whatever we find here for the area and times it by 2, because there's 2, and then we'll get the whole rhombus. That's the way you have to do this problem. So it takes a lot of thinking on this one, but you use your hero's formula, you know? So again, the hero's formula is in 2 steps. So this is 1 and this is 2. So here we go. First of all, we have 2s equal a plus b plus c. Okay, we're just going to do half of this, remember? Half of this rhombus right here. So we're going to have 2s equal a plus b plus c. So we're going to say a is 10 plus 10 plus 12. So 10 plus 10 plus 12 equal 32. So now we divide that by 2 because it's 2s, and we get 16. We're getting low numbers on these all, you know, so it's pretty good. So now we have s over here, so we can plug it in just the way it is. So we plug in 16. So we have s times minus a, s minus b, s minus c, right? That's all it is. So now we plug it in. 16, and 16 times 16 minus 10, times 16 minus 10, there's 2 10s, times 16 minus 12. That's we're doing this. So we're going to do this little triangle, and then we're going to double it, because there's 2 of these triangles in the rhombus. And so we plug it in. So we have 16, and 16 minus 10 is 6. 16 minus 10 is 6 again, and 16 minus 12 is 4. So we have 16 times 6 times 6 times 4. Well, if we look right here, 16, right away we can say 16 can be squared out. So 16 is 4 times 4. So I took that 4 out and got rid of this 16. And so now you have 2 6s. So I can take both these 6s out, because 6 times 6 is 36. And I could take that 6 out. So I have 4, I took the 4 out, I took the 6 out, and look it, I could even take the 2 out. So I took the 2 out. So now I have the whole square root now is gone. I don't have any numbers left in that square root. So now I have 4 times 6 times 2, because I took the 4 out, I took the 6 out, those 2 6 square out, I took that square out. So now we have 4 times 6 times 2. So 24 times 2 is 48. So now I know that the area is going to be 48. Okay, better not leave it there though, because what did we find the area? We found the area now of this triangle, and there's 2 equal triangles, so I have to times 48 times 2. So there are 2 triangles in the rhombus, so 48 times 2 is 96 square inches. So this one took a little figuring. And now if we go back here and we found this side, we could multiply it, but since we didn't have both, we couldn't do this part of it. We just had to use hero's formula, because we had hero's formula, like, yay, we have all 3 sides. We can plug it into our formula, our Einstein formula. And here, that's the end. The end of that. So, I'm going to quit there, and then we'll go on with the test on the different ones, just so the test can kind of be together. And then we're going to do all the constructions. The next couple quiz are constructions, but I'm going to have to do them all together. And I'll do all the constructions we have on one video. So.